beautiful and the most powerful creation of the human spirit. Numbers are the integral part of our everyday lives. Right from the number of hours we sleep at night to the number of hours we ran around the racing track and much more. In mathematics, number is a very basic compound which we are used for counting, measuring, indexing, etc. We have different types of numbers based on their properties such as natural numbers, whole numbers, rational and irrational numbers, etc. Here, we are going to discuss about the discovery of irrational numbers.
Hippasus was rumored to have been mortally punished by the gods. But what was his crime? Did he murder guests or disturb a sacred ritual? No. Hippasus' transgression was a mathematical proof, the discovery of irrational numbers. Hippasus belonged to a group called the Pythagorean mathematician who had a religious reference for numbers. Their dictum, all is numbers, suggested that numbers were the building blocks of the universe. And part of this belief was that everything from cosmology and metaphysics to music and morals followed eternal rules, describable as ratios of numbers. Thus, any number could be written as such a ratio, 5 as 5 upon 1, 0.5 as 1 upon 2, and so on. Even an infinitely extending decimal like this could be expressed exactly as 34 upon 45. All of these are what we now call rational numbers. But Hippasus found one number that violated this harmonious rule, one that was not supposed to exist. The problem began with a simple shape, a square with each side measuring 1 unit. According to Pythagorean theorem, the diagonal length would be square root of 2. But try as he might, Hippasus could not express this as a ratio of 2 integers, and instead of giving up, he decided to prove it couldn't be done. Hippasus began by assuming that the Pythagorean worldview was true. The root 2 could be expressed as a ratio of 2 integers. He labeled these hypothetical integers p and q, assuming the ratio was reduced to its simplest form. P and q could not have any common factors. To prove that root 2 was not rational, Hippasus just had to prove that p upon q cannot exist. So, he multiplied both sides of the equation by q and squared both sides, which gave him this equation. Multiplying any number by 2 resulted in an even number. So, p squared had to be even. That couldn't be true if p was odd, because an odd number times itself is always odd. So p was even as well. Thus, p could be expressed as 2a, where a is an integer. Substituting this into the equation and simplifying gave q squared is equal to 2a squared. Once again, 2 times any number produces an even number. So, q squared must have been even. And q must have been even as well, making both p and q even. But if that was true, then they had a common factor, which contradicted the initial statement. And that's how Hippasus concluded that no such ratio exists. That's called a proof by contradiction. And according to the legend, the gods did not appreciate it being contradicted. Interestingly, even though we can't express irrational numbers as ratios of integers, it is possible to precisely plot some of them on the number line. Take root 2. All we need to do is form a right triangle with 2 sides each measuring 1 unit. The hypotenuse has a length of root 2 which can be extended along the line. We can then form another right triangle with a base of the length and a 1 unit height, and its hypotenuse would equal root 3, which can be extended along the line as well. The key here is that decimals and ratios are only ways to express numbers. Root 2 simply is the hypotenuse of a right triangle with sides of a length 1. Similarly, the famous irrational number pi is always equal to exactly what it represents. The ratio of circle's circumference to its diameter approximations like 20.
Hope you had an informative session today. It's me Lakshmi Nandana I from Plus 2 BioB signing off.